Welcome to this presentation, still continuing with the CGS series and the angle trisection solutions. In this video, I'm going to look at the general solution or overview of the Alex method with the aid of the GeoGebra software. I opened the software from this hyperlink. There are conditions governing this solution. One is it should be done in the spectrum of all the angles between 0 and 30 degrees, inclusive of the 30 degrees angle. And again, the other condition, I'll demonstrate that from the construction. And this is how I begin the construction. I need to draw a straight line between 2 points. So I pick those as my 2 points. I use some tools on the GeoGebra toolbox packages, or toolboxes or block sets, and they'll assist me in performing the construction. I do not need to teach about the use of GeoGebra here. You can find that in different tutorials. So that being the case, we have started with the construction, and I'll need first to generate 30 degrees. I'm going to start with trisection of 30. And to do that, first make 60. Just observe the constructions. I'll pick another tool from here for the angle bisection. To bisect angle AB, angle CAB at this point. That's my 30 degrees based on Euclidean geometric understanding. Okay, I need to join the points B and D using a straight line segment, and I'll pick it from this toolbox. That's it. I sharp the compass there and align the ruler along the 2 points D and B and draw the straight line. I'll mark this in red to show that the line of interest will be trisecting to help us achieve the target results or the targeted result. I can put it in another color, not necessarily red. That's how it looks like. Now I impose the second condition after making the 30 degrees. The configuration of 30 degrees. So the second condition, I impose it using this tool. I can lay a point or a center, a midpoint or a center between 2 points using that tool, and I have my point E here. Again, since I'm going to demonstrate the entire proof, I will use some geometric transformation tool to reflect the point B about point A to give me B prime at the end or the other side of the circumference in the baseline as this. With that, I'm almost set. I'll also need to map point E about point A that way. I'll use these points in performing the trisection of this line. How do I do that? Before I begin, I need to join this DE prime with a straight line, and since I want to draw other lines parallel to that, to highlight the property, I give it a different color. I will start the construction of or the trisection of the line, and this is how I'm going to perform it. I make that, and that. Let me leave the circles black and choose the labeling tool here to label this point of interest as point F. That's the point I'm interested in or at. Using the compass tool, I pick this segment AF and make 2 small circles or curves. Using the compass, they will just be curves. I'll turn the appearance of this in terms of color into something like that. And again, the other one too. I give it the same color for appearance or uniformity. I'll use the labeling tool to label this as a point of interest, point G. I can zoom in the figure for accurate labeling of this point of intersection between these two curves or arcs. I pick the tool again and label this. I'll zoom out the figure to come back to my drawing pad or for clarity purposes. I will use the straight line tool to draw a straight line through points A and G, and another one through points E and H. As you can see, I said I need these lines to have some common characteristic. They are parallel. They are trisecting the chord BD, and that's why I'm giving them same color for good view. Now my interest is the points of trisection of this line, and I zoom in the figure so that I can accurately label these points to avoid so many errors. You can either zoom out or zoom in the figure to bring this down that way. Now I got what I needed. We have executed the both conditions and Alex's construction. Now next is to investigate the truth of the results. Using point E prime, I make a line through J, and using point A, another line through this point of trisection the curve. That's point I. Yes, it is high. I'll zoom in the figure again so that I can label another point here accurately. It exactly passed through point I according to my observations. This is the point I'm interested in, point K. I zoom out this again and I label this as point L. Now the general proof looks like this. Remember, I made the point B prime here because I preserved that one for later use, and this is now the time for its purpose in the construction. I will pick points L and K from this algebra view window and I place them here. I have carried the angle they have cut on the curve. I'll give them maybe this color. That's better. Sorry, the curve that, and label this as point M. That way. If I joined M to A on a line segment like that, let me give this a different color. I can pick this now, which appears to be the real red, that way, and use the angle measure tool. I get this, that, and that. It's appearing to be 10. The process is not complete, however. We need to justify that is 10. So I'll perform the proof complete, geometrical proof for that matter, and this combines several properties. One of them is the use of the compass equivalence theorem. I have not violated any condition in straightening the curves or moving the curves from point to point, transfer of distances. That is not prohibited since I'm not the first person doing that. Again, the assumption is this angle 2 should be 10 degrees since I'm assuming this radius NM and MA, they are commensurate or equal. I love using the term. That is it. I'm getting 10. The angle DAB was 30 degrees. We can estimate that again. Yeah, that was 30 degrees, and that's how you trisect 30 using my method. The points to note is this point of intersection or the central point between A and B, and the method works in this configuration between 0 to 30 degrees inclusive. That is it. That's how simple it is to prove Alex's method. You can stretch to 3 decimal places and see the results. can search that from the GeoGebra view. And I'm getting 10.001 and 9999, 9.0999. That's quite reasonable. So that's how we can trisect that using Alex's method. The method works generally for all encores you need. You can test that in another encore you can construct, provided you reduce it to fit between this configuration 0 and 30 degrees, and remember to impose the central point between the baseline in the ray substating the encore you intend to trisect. That's the end of the trisection of 30. Now we'll perform it in real environment, assuming you do not know the encore you are given to trisect. Just any 3 points subtending an encore at a common point. We call it the vertex. That's what I'm going to do in the next video. This was the general look at it, and we have demonstrated even to the proof. Thank you very much for viewing. That's the end of the presentation.